some examples. Hopefully everyone has a terminal session open somewhere so that you can type along. Maybe search for some of these examples yourself on your own system. For this chapter, we're going over a bunch of examples of typical software modules that are installed, so that you can see how to find them, how to load them, and any of their prerequisites. Also, we'll be showing how to find out if Python packages are installed as their own modules or as extensions of other modules, and how to find R bundles of or bundles of R packages installed as modules if they exist. So we already looked at tool chains, and now we'll look at some more typical modules. Loading modules works pretty much the same way, regardless of whether the module is a standalone package or a tool chain or anything in between, and with or without prerequisites. The procedure is almost always some variation of this three-part process here. You use Module Spider to see whether a module is installed, and if so, view the available versions, and also get the correct typesetting and other details about the names. At facilities without a hierarchical structure, you might choose instead to use module avail instead. Once you have a version picked out, you just do module spider package/version to view the prerequisites for that module, if there are any. If it can be loaded directly, it will say so. And then you just load the modules with either one at a time with ML prerequisite, ML package, or you can load them all on one line if you're really confident. Sometimes it helps to split them up just so that you can know exactly where an error is occurring if something is incompatible or if there's a typo. But a lot of times it's still pretty safe to just load the prerequisites and then the package that they're prerequisites for, all on the same line. Did I see any hands or? Okay. Don't see any hands. Most of the examples below used outputs from Cosmos, but the workflows will be similar at other institutions unless otherwise specified. Okay, a couple of quick notes before we go on to the actual examples. For both R and Python, the packages very often include a lot of what are called extensions. Typically, we would refer to these as modules if we were not already talking about LMON modules. But when we're working with LMON modules, we call these other packages dependent packages extensions. These can be found with ML Spider, or these cannot generally be found with ML Spider or ML Avail, but they may be visible in a if you know the package that contains them, or you at least have a suspicion, you can use ML Show on a standalone package to view the Lua module file, and that usually has a section on included extensions near the top. For example, let's look at the SciPy bundle. So ML Spider SciPy bundle, feel free to type along. If SciPy bundle is not available at your facility, then it's probably something that's included in the top level Python distribution. So let's look at this one, ML Spider. So that requires GCC 13.2. And so I'm going to load this just so I can do the ML shell. So ML this. And now you don't actually have to load the package in order to load the in order to use ML show. You just have to use load its prerequisites. So now let's do ML show on this SciPy bundle. And now you see there, it has this section called included extensions. And here you can see that it contains SciPy, it contains pandas, it contains NumPy, num expression, and a few other packages that are less often used. But anyway, this is where you have to look to find NumPy and pandas and SciPy. And if you can't find them, or if another package gets loaded when it's pulled in, so let's say I go ahead and load this SciPy bundle. Now, if I look at what's loaded, it didn't just load the SciPy bundle. It also loaded Python, it loaded cryptography, and it loaded this Python bundle, PyP. So it will. I should have shown something else first. Let's back up and do ML purge. So ML GCC, and now I'm going to just load Python. So if I look at what was installed here, the toolchain, the GCC compiler, and the GCC compiler was loaded. A few others were loaded by the GCC. Most of these were loaded by the tool chain that was pulled in by loading Python 3.11. And if I do pip list, the number of packages that Python includes is very small. But then if I then load SciPy bundle, and then I do pip list, well, there's a lot more packages that are included in here that were not accounted for by just Python and just SciPy bundle. So sometimes it's helpful to look at the pip list if you're not sure if you're not sure whether or not packages that you've loaded already accounted for an extension that you need. So let's see. One of the things I actually showed this later in an example. Maybe maybe I should have waited for that to make a little bit more sense. Anyway, oops. Let's reset module purge. One more tip before we move on. grep does not work directly on the outputs of module commands. So if you want to search for an extension in an extremely long Lua module file, you'll have to get the copy of the full path and then then pipe the output of something like less or more, and then the name of the file to grep. And if there is no output, the extension that you search for is not present. All right. We already touched a little bit on Python packages. It varies between centers how many packages are installed with the base Python packages, how many are installed as separate modules, and what prerequisites are required. Apart from PDC is the main exception to this, but there are also some quirks with UTMax and NSC. So I'm not going to go through all the details here. They're there if you need them. I will highlight that NSC. I will highlight again that NSC always requires this build tool, easy build, as a prerequisite for even tool chains. And I will highlight that at PDC, the basic Python distribution that just says Python and then version numbers, those are misleading. Those are very bare bones versions that are not really compatible with anything else. If you want a more expansive version that's compatible with other modules that are already built in, what you want is actually this Cray Python. So whereas at most facilities you might use Module Spider Python, at PDC you want to use Module Spider Cray Python, unless you're looking for a distribution in which to create your own environment. And most programs on .rel require this extra PDC and PDCL prerequisite. All right, let's start with matplotlib as an example. The prerequisites for this vary a lot across different HPC centers. Some require none, some have one prerequisite, some have two. Some cases, matplotlib is only an extension of another module. I have a link here on that goes to another course we provide that gives some information about what versions are available and how to select them at different facilities. So that's a good reference if you have if you're looking. So a good starting point is generally to view the output of ML Spider or matplotlib. If it doesn't show up, it's one of those packages that is included as a built-in option. So like on Rackham at Opmax, let's see, what have I loaded? On Rackham at Opmax, it is included as part of the Python, the built-in Python version. So what I've included so far are examples taken from Cosmos. So if you do Module Spider Cosmos, this is what you get. Module Spider matplotlib on Cosmos, this is what you get. So you can try that on your own facility. Let's look at a particular. Then you pick out a version just to see what kind of prerequisites it might require. At this stage, you might not need to choose a particular version yet because you'll be constrained by one of two things, neither of which is the actual matplotlib version. Typically, you'll be constrained by GCC. So like, for example, when I pick out the matplotlib version, I'm just showing it because it shows that it's dependent on GCC. So that's the only thing that technically needs to be loaded before you load matplotlib. However, for all practical purposes, matplotlib is unusable without the tools needed to read in or create the data that is used to plot. So even though it's not explicitly required, you typically need a SciPy bundle or whatever else provides NumPy or Pandas. Also note that the output of Module Spider does not show the version of Python that is associated with it. If you know you're only constrained by the GCC version, then you can just load everything directly like this. But typically what happens is that you start with a code that you've developed on your own laptop, and the only thing you know is what Python version you're constrained by. And usually these types of codes are relatively flexible, so you can actually pick from a range of versions. So let's say you built a matplotlib script based on Python 3.11.8 on your own laptop, which you would find with Python -- version. Glob patterns don't work to filter ML Spider, ML Avail, so you'll need to do Module Spider Python or Module Spider Cray Python to find the available versions. So let's do that. I'm going to do this on Tetralith now, just to be different. Module Spider Python. So actually on Tetralith, this is one where it's better to do Module Avail Python. So now we have all of these versions. On both Cosmos and Tetralith, the closest version that's available to 3.11.8 is 3.11.5. Generally, it's best if you can match this, at least the second set of digits in this 3-number sequence. So this is the major release. You always got to match that. This is the minor This is the sort of medium release. Usually you're okay if you can get within plus or minus one of those, unless there are a few quirky exceptions that I won't go into today. And then you can this last number you can kind of ignore most of the time. So let's look at Python 3.11.5. On Cosmos, let's do ML Spider Python 3.11.5. Now that shows GCC Core 3.2. Quick word of advice: if you see GCC Core, 9 times out of 10, it's better just to load the full GCC Core, because almost everything else that gets loaded in addition to Python depends on the full GCC, not just GCC Core. Now let's do the same on Tetralith. So ML Spider. I'm going to look at this one, not the bear. This one's nice enough to listen some additional extensions that are available to be loaded with this. Let's see. The included extensions is fairly short, but this is another package that has SciPy where SciPy bundle and PyP bundle are available. And now let me do ML avail matplotlib. Now this is a little bit of a problem because if I do ML Spider matplotlib, there's exactly 2 versions available. So if I look at what module spider, what 3.8.2 depends on, okay, so it's the same GCC, but the that's right. It's again, the build tool needs to be loaded before you load anything else. So that's why we couldn't see. That's why we couldn't see it before. So on Cosmos, if I want to, now that I know I need GCC 3.2, I can just do, I can just copy and paste all of this in here, and then view all the modules that get loaded. So Matplotlib typically pulls in a lot of visualization libraries. The most important one that you want to make sure is present is tk-enter, because that's what allows you to view whether or not there are that's what allows you to interact with the GUI. Now on Tetralith, I need to first load let's say this one, this build tool. And now this is a good chance to look at what happened to the version changes. So if you change tool chains or you change prerequisites, the module system tries its best to adapt for you. And in this case, it was able to change everything that was necessary. So now I can load the GCC 13.2.0. And then, and now that's changed a whole bunch of things as well. Now, let me do ML avail Python. And this is not really, so this is, now I should be able to load this without issues. ML Python, ML, and matplotlib. Let's see what happens. Yes, so now it's all properly loaded. In the interest of time, I'm going to skip the MPI for Pi example because it's pretty much the same procedure, except that Bootmax does not currently have an MPI for Pi installed. You have to install it yourself. The only major difference in the dependencies that you'll see is that it, in addition to a GCC, it also requires an open MPI. And so in this case, it's often quicker and easier just to load a full tool chain. So, and I already went over finding out if an extension was loaded silently. So let's say I want to see if this PSUtil was loaded. So I want to, so in this really long list, I can almost guarantee you that it's loaded. In fact, I know it's loaded because it comes with this Python bundle PyPI. But since this bundle is pulled in by other packages silently, you don't always know, you're not always conscious of what's being loaded with it. So let's look at, oops. So let us look at the output of pip list and grep for PSUtil to see if it's there. And yes, it is. And this is handy. This is also handy if all you want to do is check for the version of a particular thing. Like let's say I want to check if what I'm running is NumPy recently had a major release that upgraded it from 1 point something to 2 point something. So now I want to see what that is, because that could dictate whether or not some older packages can still work. So let's look at NumPy. This time it's still running a 1 point something. All right. And if you happen to be using Anaconda instead of the PyP distribution of Python, you can use conda list instead of pip list. And this is really handy because Anaconda includes a whole lot of things all together in one package, including like NumPy, pandas, matplotlib, all the works. And unfortunately, the module file does not list any of the extensions. So in this case, conda list and then grepping for a package is the only way to see if a package is included without starting up Python. All right. Running very low on time. So here's some little bit about R-based packages. In most HPC centers, the base module contains relatively few extensions. So most of the popular packages are included in additional bundles like R-bundle CRAN or R-bundle bioconductor. Or on Bootmax, there's this, instead of either of those, you have module purge, ML, Bootmax. I believe it's R mail-avail R packages. Yeah. So on Rackham, instead of R bundles, you have this R packages selection. So that's a little bit unique. On Tetralith, R can be loaded directly, but it contains very few installed packages and there are no bundles to provide more. So you have to install your own. It's expected that you maintain your own extension libraries on Tetralith. And it's kind of similar on PDC Dardel, except that the usual PDC prerequisite is required, but the compiler and the MPI library are chosen for you. And there are only about 250 packages in the basic R module, whereas for comparison, the CRAN R bundle and the bioconductor R bundle, between them load literally thousands of packages. So it's one important note: most facilities have only a handful of R releases that have been built because because building is so intensive. So usually there are multiple dependent versions. So usually the dependent modules have multiple versions that are adapted for each R release. So you need to specify the module versions. You can't just let you shouldn't just let the version number of the dependent modules be chosen by the prerequisites, because that will load the latest version by default, but the latest version is subject to change. So let's briefly look at bioconductor. So if I were to look at module spider bioconductor, it pulls out this. It's a partial match to this string. Let's say I didn't necessarily know that bioconductor was part of our bundle bioconductor. Well, now I do. Now I do with module spider. So notice that there are two versions of bioconductor 318 for two different R releases, and there are two different R versions. There are two different bioconductors for R version 4.1. So that again, that means you need to choose the version. So let's look at module spider R bioconductor. First on Cosmos. So here you can see you need GCC and OpenMPI. And if you scroll down and try to look through the extensions, it will take you forever to get to the end. Some of the more important modules included are listed right here. If you want to load them all at once, you can with this by loading MLGCC 12.0, 3.0, and so on. And the R bundle bioconductor actually loads, like if you, I think you can scroll up a little, no, it's at the other end of the module file. So, whoops. So if I scroll if I were to scroll way down all the way to the end. Oh, no, it's not in that module file. Dang. Well, it does pull in R 4.1 without, silently. So if I were to do, if I do this, what had happened? What do I have loaded? Oh, that's why. I'll purge. All right, let's try that again. Oh, that's why. Now, if I look at ML, there are about 130 modules that get loaded, including apart from the bioconductor. All right. Now, MATLAB and specialized applications for these sections, since we're short on time, I'm going to just sort of briefly summarize them. In most cases, these can be MATLAB and other sort of specialty packages that aren't built on, that are in other more specialty packages. Most of these can be loaded directly at most facilities, apart from the usual prerequisites on NSC and PDC, or yeah, PDC. So let's say open, like for instance, open foam. This one, if I do on Tetralith, let's do ML purge. The ML spider open foam. If I do that, I can see that there are a whole lot of different open foam versions, and the vast majority of them are built on Intel tool chains, which is to contrast with open foam on Cosmos, which is most of these were built with GCC toolchains. So if we look at a recent version, like so, you'll see that you need to load GCC and OpenMPI as usual. All right. I've not left very much time for the modules and batch scripts, so but we were already running about 5 minutes late anyway. So Brigitte, will you? Well,